Magnetism activities are also a great way to incorporate probes and probeware into your science classroom. You can get magnetic field sensors available from many of the supply companies that deal with probes, including Vernier and Pasco. This in particular is a Pasco probe, and you can connect it to computers, you can connect it to standalone devices, and you can even connect it to an iPad. I have here an AirLink device, and in this case you would connect the probe into the AirLink, and then you would sync the AirLink to your iPad through Bluetooth. Let's take a look at how this might work. Now what you're going to do is you're going to take your magnetic field sensor and you're going to plug it in to the AirLink. You'll have to connect the AirLink device to the iPad wirelessly. But once you have that, this device is now capable of measuring the magnetic field strength of materials. So in this case, I have a neodymium magnet. If I were to bring the magnet near, it would register the magnetic field strength in Gauss. It's important to note if I turned it around, I would measure the opposite pole of the magnet, and it would give me a negative reading in Gauss. And this allows us to do a number of different experiments. Students could test the magnetic field strength of the magnet as you move it further and further away. You could put a variety of materials in between and see what effect shielding might have on it. Or you can take the sensor itself and you can go around the room and measure the magnetic field strength of different materials. And then you could bring magnets near it. And in fact, your students could come up with a whole host of ideas that they could explore using this type of setup. The real advantage in using probeware is that it allows you to collect data that might not otherwise be easily measured, and it gives you access to that data very quickly. Let's take a look at what this would look like on the iPad itself. The first thing you'll need to do is to connect your AirLink to the iPad via Bluetooth. Go into Settings, choose Bluetooth, make sure it's turned on, and then you can connect the AirLink. Each AirLink has a number printed on the back of it. Once you turn it on and you bring it near, it'll automatically connect. Then you can go out and start up SparkView HD, and the magnetic field sensor will appear. In this case, I've chosen to measure it in digits to get numerical data. What you see happening now is that I'm bringing the neodymium magnet close to the magnetic field sensor. First the one pole, and then I turn it around so that the opposite pole is now appearing, and you see the numbers went from negative to positive. But that's only one way to view your data. I can go back out and I can choose magnetic field sensor and instead choose a graphical option. In this particular case, here's that same data with a graphical look to it. As you see, I move from one pole to the other. The SparkView app also features a notebook portion. In this case, I've selected the graph. I can type in a title or other information using the iPad's keyboard, and this will allow me to provide information about the items I select. Another advantage of the notebook is that it allows me to access the photo library so I can include images I take along the way. Finally, the app allows you to include statistical analysis. By clicking in the right spot, you can get the statistics to pop up, and in this case, I could take the mean of this, but you can see there are other statistics that you can use to measure. If you have further questions about the use of probes, I would suggest going online and searching the websites. Both Vernier and Pasco have a host of resources available on their websites that allow you to get started very quickly. And if you're near a conference, stop by their booths because you can get a hands-on demonstration of how this might work in your classroom.